Okay, so today it is March 18th. Today we're going to talk about data wrangling. I've got a neat little presentation that we're looking at. I've got a neat little presentation that we're going to look at that were created by some other people at another school, but it's going to focus on some of the salient points related to data wrangling. I think my skill set, when we get into my skill set, it's how do we turn whatever's going on out there into something that we can put into ArcGIS Pro and make maps of. We're going to look at a couple examples. Chantel's here with this, and we're going to look at gun deaths in North Carolina 2019 or 2021, latest gun deaths. And so we got to figure out what are all the things that we need to think about. What scale of data do we have? Because there's a lot of HIPAA privacy issues out there that we can kind of look at and address. What types of data are available? I teach a crime analysis class, and if you just saw a map with all the crimes on it, that's great, but you don't know what day of the week, what types of crimes they are, and all those other things. And so when we start looking and delving into the Vital Statistics database, and today we're going to click on the database, download the data. We're going to look at the different file formats because I saw an interesting quote in here where that like 80% of all of your kind of project is just working to get the data so you can make the nice, pretty maps. And I think Cameron's really kind of gotten into the weeds on some of these things because when I look at 2019, 2018, 2017, I could do something called a merge where we merge databases. But when we start looking at this Vital Statistics database, we're going to see this big schema change between 2014 and 2015 where they started changing all the attributes and the naming conventions. And you got to go through each of these 60 attributes and figure out, all right, BTH state is now B underscore state. You're like, well, who decided that? And I'm sure there's a reason for it. And so I want us to kind of get into the weeds a little bit as to what does this data look like? Because the days of you opening up a map and Mulrooney's data just appearing for you there, for you to do stuff, that stuff's kind of starting to come to an end where you're going to be the ones creating the data. Because I don't want to say I don't care about gun deaths, but I don't want to map gun deaths. I want to map, other types of deaths or other types of phenomena. And we're going to look at the North Carolina voter voting database and just download the registered voters for one county. How many voters do you think are in one county? We're looking at tens of thousands of these, and we look at a statewide database. It's going to be something that Excel can't handle. And so we can bring some of these things directly into a GIS. And more importantly, we figure out how to map these. I want to map the percentage Republican, Democrat, all these, different fields. And I think figuring out how to turn all the multitude of data out there into a database and putting into ArcGIS Pro so we can make our reds and our greens and our blues and our clusters and all those other things I think it's important. One of the things we're talking about too, a couple of things I want to mention is that later this week we are hosting the North Carolina Geographical Society Symposium, and then in a couple weeks we're hosting. This building is hosting GURPS. The Graduate and Undergraduate Research Symposium. And I've kind of started to point out to people, I know Andy's new here, Michael's new here, Chima's not new here, but I'm starting to point out to people, hey, let's present something. You doing the stuff for me, that's all good and well, but you kind of getting out there and working with folks at ECU or other places, it's important. A lot of times, I hate sounding like your parents or whatever, but a lot of times it's not what you know, but who you know. That's important. Who you know. Because eventually, if you don't know anything, people will figure that out and you kind of go on your way. But if you know all this stuff and you just want to sit in the corner and do your own little thing there, then that's going to be problematic as well. And this is a paper here called Using Raster-Based Point Density Calculations to Assess and Evaluate the Availability of Food Sources. And a lot of times I talk about the idea. I'm going to talk about this a little bit because these are some things that are, I think, a little bit near and dear to my heart. Because a lot of times when we do research, when I first started at Central, I wanted to like map like college wrestling programs. And what do you think the problem with that is? Why is that a problem? Because no one's going to give you money to do map college. They're not going to give you money to do that. And so my first year I came in, one of our students came in and said, I want to map food deserts. I'm like, well, what's a food desert? Well, it's an area and largely in typically in underrepresented populations or neighborhoods with underrepresented populations would have a high poverty component and are far from healthy food. And I'm like, yeah, that's cool. I can measure far. This is GIS class. And you know what? There's lots of money out there to measure food deserts, healthcare deserts, health mapping, cancer mapping, all these things that help dictate inaccessible access to resources. That's important. And these are further exacerbated by the idea that people don't have access to individualized transportation. And so I talk about this raster base because I think everyone has talked about this. I'll talk about my presentation a little bit and the idea for this paper and kind of some of the interesting things that we're looking at. This is based on a USDA grant that I've got. I've still got a little bit of money on it. I'm trying to spend it all, but we measure like food availability because I drive through the neighborhood and I pop onto the Beltway and I go all the way to Greensboro. I don't drive by a lot of supermarkets, but I drive by a lot of houses. So what do the people eat there? How far do they have to travel to access healthy food? How do you measure availability? What are the different ways to measure food availability? It's getting deep. You didn't think you'd be thinking about this at 509 in data science class. And we look at the pillars of food security, food availability. How close is food to you? Okay. And there's lots of different ways. Food access. If food is half a mile away, if you don't have a car, it might as well be 50 miles away. Right? Are you going to walk half a mile? No, of course not. I'm going to walk to the corner grocery store and buy the junk and the 75-cent bananas instead of the 52-cent a pound bananas. And then also the idea of food utilization, which means even though they have a farmer's market or healthy food next to me, are you still going to drive to get fast food? And I thought it was interesting, and I think I've mentioned this before, where that, we have a rental home. We have a rental house at our home. And it's out in the middle of nowhere, northern Greensboro, Guilford County, and it's right down the street from Lowe's Supermarket, which is pretty good. And we go and clean up the garbage because my wife and I are too cheap to hire people because we just want to keep all the money for ourselves. So we go and, on Tuesdays and Thursdays, or not tonight, I'll go and clean out the garbage. And I go and clean out like lots of fast food. And the nearest fast food, it's got to be at least 10 minutes away, maybe even 15 minutes away. And that people go out of their way to go to fast food when there's a much easier, and even though Lowe's costs kind of a lot compared to Food Lion or Walmart or anything like that, other option. And so the idea of food utilization with the end state of food stability. And I'm kind of starting on this presentation because when we talk about how do you measure food availability, we can measure something like proximity. How close is food to you? Because for you versus your neighbor, because when I group this, if I were to look at a map of 100,000 addresses and how close they are to food, what do you think that map's going to look like? It's going to be busy. You're not going to know what it means. So we can group it by zip code. Typically, we use the term enumeration units. Now, where am I going to measure it from? I can measure it from the center of the enumeration unit. I know people in this room know what the word centroid is. Good. I see heads nodding. Very good. But we know what centroid is. We can measure it from the center, but that might not be a good measure. Just if a healthy food source, which is measured by the green star, just happened to be really close to the middle, and there's nothing else there. And so we can measure it this way, and we can calculate these average distances to, to the store, but we have various gaps that exist. We can measure things like proximity. Another way to measure proximity is drive time. Drive time takes a little bit longer to measure, but we can measure Euclidean distance, which is straight line distance, and we can measure drive time. And so that's a little bit better measure, because a lot of times when I go on my phone, I don't care how many miles it is. I care how long it takes me to get there, so I don't have to hear my kids fight in the car. And so, but I can do this for all the homes here. And I can do it for all the homes and maybe average these up or something like that. But even measuring up a couple thousand distances still takes a long time. And I also measure the areas around it. And so I thought this was kind of neat. We can look at this, and we can look at like average drive time to healthy food, average drive time to unhealthy food. We got units like measures, miles, total number, all these other things right here. But it starts to be very resource intensive. And what we started to do, we got a paper a couple of years ago where we said, hey, I don't want to measure, and we did this for Guilford County, I don't want to run 220,000 network calculations, just like we did like geocoding like we've done in class recently. And so we did some approximations for different modeling techniques, which are best. And we found that the population weighted centroid works almost as well as doing every single brute force location and then averaging these up. So population weighted centroid, does everyone remember what that means? It's the centroid just weighted by the population. So where the middle of the population is. So if it's on one side, it's going to be skewed in that direction. And so we did some really neat two-tailed t-tests, and we looked at, so we see this word t-test. We all know what that means, and we're going to talk more about those next week. Today, we're going to talk about some basic descriptive statistics here, because if we're doing hypothesis testing, we can at the very least say that. We got this paper here out. Richie was a former student of ours who was a non-traditional student, came here as an undergraduate student. He kind of moved out to Canada to do some work here. And then, but when we look at all of these measures, we've got types of metrics, because I can't compare miles to minutes to number of stores. And so we started to look at like relative metrics, which are unitless, meaning it's like 3 times further to healthy food than unhealthy food. And this is what we call this pixel-based, food balance scores. We have lots of other things out there. And so what we tried to do in this research was we started to look at density, okay, raster-based density. I know a couple people are kind of new to the GIS game a little bit, but when we create raster surfaces, it's like creating temperature surfaces or drone imagery that we have. You zoom in, we got little pixels, but in this case, it measures how many Dollar Generals are within a certain distance of you. And we can set up that radius. And we did it for this. And basically, this is what it looks like. This is what this map looks like. So you can see these areas which are darker have a higher density of Dollar Generals compared to these areas that are lighter. And then now we can kind of group these by block groups, which are subdivisions of census tracts. And I know in your class, you guys talked about block groups. And the thing about block groups is, well, I love this map, but I like this one more because I know how many people live in this area here. I know how many people live below the poverty line. I know the median household income. I know the number of people of Danish, birth or whatever for these. And so I can start to make socioeconomic, social relationships between access. In this case, we were looking at Dollar Generals. And I've been kind of more fascinated about Dollar Generals because they just built one. Just the house that I was talking about where people move across the street from the Lowe's, they built a Dollar General, and no one wanted the Dollar General. No, why don't they want Dollar Generals? You can say it out loud.
There's a pretty negative stigma.
There's a negative stigma with it. To me, the stigma is like I go there to save money. So I can go across the street to Lowe's, pay twice as much for paper towels, or go across the street there and pay half the amount. And this Dollar General in particular has been, and basically these Dollar Generals are starting to fill the void where large supermarkets aren't. And so they kind of fill in this rural void here, and also people who want to save money void. And so they've got milk and eggs and bananas and all that other stuff there, which are actually cheaper than Lowe's. But one of the things when we start making these maps, we look at this point density, 0.53. We can start to look at other metrics there, but how do we compare these? Because I'm comparing this density, which is 0.53 versus average drive time, which is the number of stores within 3 miles of this. You can't get these units to agree. How do you make all these units agree? It's difficult. And so we can start to group these by most available, least available, quintiles. And quintiles hopefully start to ring a bell with us because these are things we talk about with two-tailed t-test and ANOVAs. And I know, we're kind of getting out of sorts a little bit because I made another map here. And this is the number of stores within 3 miles. And so this store right here, or this block group, has between $12 and $18 generals within 3 miles of this right here. But these are different, and so I can start to look at these various metrics and start to compare these maps where using one method, these are our most available, least available, or neither. Another method, we've got most available, least available, or neither. How well do these maps compare? Are they close? How do you, man, I'm getting deep here. This is like, what is it? To me, I think this is neat because no one's really thought about this. Like, because what did we do in geostats class? We had clusters and crime rates and income, and we wanted the blue and the red and the yellow. Right? That's all I wanted. The blue, the red, the yellow of crime rates or whatever the heck we're looking at. And now I'm already busting out most available, least. I don't have numbers with these. And I converted these from numbers to categories because we've got these different units here like 0.05. Well, this thing was like 17, 0.05 dollar generals per square mile, where this one is $17 generals per block group. And so once again, we got the apples and oranges that I've talked about in crime mapping class. How do we compare these? How do we assess and evaluate these things? And so I like this here, and this kind of gets into this thing called the Jacquard Index. This is this is gonna be like my dying wish to have people like this, but I don't think it's gonna happen. Where that, we look at a couple of maps right here. What are the chances these two maps are statistically the same? And this gets into what we call nearest neighbor analysis, NNI. Or NNA, I guess, which was the nearest neighbor index that we talked about in geostats. We got a bunch of points out there. What are the chances they're clustered, they're random, or they're dispersed? We just threw 50 points up there, And so I'm kind of getting into this, but when I look at the paper here, and this is what I'm going to be presenting because I really like this paper. Where it gets into dollar generals, but when we look at the assessment and valuation, when I compare those maps, when I can compare this point density versus this buffer 3 miles, that map that you looked at before was 0.78, meaning 78% of that map actually agreed with each other. And I think this is not this. So even though they don't look the same, these maps agree with each other 78%, meaning the dark areas match the darks, the white match the white, the yellow match the yellow. Even though, look at this county up here, it's totally, it's one's white, one's largely dark, but when you actually look at it, there's not that many block groups up here, where we've got about 160 block groups sitting here in Durham County. And so even though these maps kind of look the same, they agree with each other 78%. Now we know what 0.78 looks like, right? We could, and 78% is just a little percent sign. Basically, 78% is just the ratio, right? And we just threw a little percent sign on there for our own personal edification. But when we start to look at these, we can start to figure out which one works the best. Hey, this point density method, this whole raster method that I went through the trouble of creating, it averaged up to be 0.65. The other one was 0.6, 0.23, 0.62, 0.59, 0.63, 0.60. Now, we did have a problem here with something called join count, meaning what's a spatial join do? Who remembers the spatial join?
It's where you can combine like your data with like already existing,
Yeah,
like on a feature.
that's a tabular data where basically we have Dollar Generals and block groups, and we count how many block groups or how many Dollar Generals are within each block group. And that's all we do. Now, how big is a block group? Some of them are big, but they're probably about, I don't know, 3 square miles on average in Durham County. It is, there's about 160 of these, and Durham County has a size of what? 400 square miles, 2 to 3 square miles. So when we start to look at this join count here, we get values of 0, 1, 2, or 3. Those are the only possible values you can get. And so it's hard to create granularity or cardinality with these data. And so a lot of times these things didn't match up because you either got most available or least available. You don't have a neither category, where that 60% of our neither category was sitting in these other things. So I removed it, but you can see how well it matches up here. And so we have a really nice assessment and evaluation piece right here. And I never use the word two-tailed t-test or statistical significance and all that other stuff that I think we get a little kind of, I don't want to say worried about, but think about a way to test it. Because a lot of times when you do your research, I want to do something on gun deaths. I want to do something on this, cancer mortality rates, all these other things. The bigger picture you start to think about is, how am I going to assess and evaluate? How am I going to test this thing? Okay. And what we did, we actually created a nice little Python tool to run it, because I could have done some field calculations, but does this thing look familiar here? Did we do this in this class or no? I think I showed like an older version of it or something like that. But I have an input layer, field 1, field 2, and we can create different calculations and compare these. So I wrote a little Python tool in support of this. And now the reason why I'm mentioning this is because this was the idea of a student came here, wanted to write this big paper, and they did a really nice job. And I didn't do any of these maps. They did a really nice job with the maps and graphs and all these other things. And I wrote this paper in probably about half the paper in literally like one night, kind of getting some inspiration, because it was kind of, we weren't really hitting the major points. And I wrote it in like one night. And I had gone to a conference in Prague, Czech Republic, and I couldn't get the train early morning. So I just spent the night in an airport and just wrote it, and I was like 6 hours ahead, so my clock was fine there. But you kind of got these kind of fits right here, or flow, or whatever you want to call it. And this is probably one of the best journals that we've published in. The Journal of Agriculture and Food Security. It's a good one. And we made it what we call open access. What do you think open access means? Anyone can read it. Okay, so you don't have to go behind a paywall or anything. We paid, I don't know, $2,600, or my grant paid $2,600 to kind of make it open access. Now, what's the advantages of making something open access? Everyone gets to read it. Like, everyone looks at Mulrooney and cites his stuff instead of having to pay. And so this is a neat paper here where we were working and thinking about how to, the trick with this was how to run this assessment and evaluation piece. And we're going to start really basic today and then kind of get into some bigger things. And I want people to kind of think about those. And today we're talking about data wrangling. I've got a little presentation up here, and then we're going to open up the project, the zip code level data, and we're going to start extracting gun deaths for the state of North Carolina in 2021. And we're going to all sit here and do it. And all of you can kind of sit there and follow me as we go through it and do this so that we can just make really basic statements. And our basic statement just might say gun deaths were higher in rural areas compared to urban areas. And we got to think about things like normalization and all that other stuff. And we'll kind of worry about that later. But we could just use the word higher. Okay, populations, all that other good stuff. And so data wrangling here is the whole idea of what are we going to do with our data? And it's, to me, I saw a couple of interesting things here about EDA, exploratory data analysis. And these days, ArcGIS Pro has looked a little bit more into ESDA, exploratory spatial data analysis. I'm just going to kind of hit on some of the salient points, but a lot of times we get this data. And a couple of the data sources that I'm looking at here that we're going to look at are, we can go to voter registration data and just start to download all voter registration data for Alamance County or the entire state. How many records do you think voter registration data is going to be for the entire state? We're looking at about 7 million records. Imagine opening up an ArcGIS Pro standalone table that has 7 million records. Another one that we have here are North Carolina Vital Statistics Database. We're going to look at the very first thing here that was published in June 2023. And I'm going to click on this right here. And these are all the deaths for the state of North Carolina. And I go here and now I see more files that I have to download. Okay, I see .data, .tab, .pdf, this SAS7B data, whatever. Okay, all this stuff here. And so we're gonna, and a lot of times these things are largely going to be software agnostic formats. And so I can bring them into Excel or bring them into something else and kind of go from there. Some other things I'm going to mention here. Some of the things that we have about, and this is kind of my skill set right here, where that we work with text data and regular expressions so that we can facilitate the reports, decisions, and other things here. Now, the other things we think about: file format, variable types, primary and foreign keys, and we can create primary keys from things like summarize. I know everyone here knows what that summarize does. It's one of my favorite things, but what are the different file formats? What do all the different fields represent? You know, we started to look at a little bit last week. You know, did I share that really big document of all the different fields that you could have? Oh, we haven't done data cleaning yet. We're going to do that in a couple of weeks. I was thinking the exercise, but we can look at that LRS database and we can look at like 90 fields for all of the, we ran a null value checker on something, right? Okay, remember that, the null value checker. We're going to look at like speed limits and possible values for speed limits and expound on that. So we got a lot of different things that we can do here. But we have issues with structure, formatting, missing or corrupted values. We're going to look at those in a couple of weeks. This week, we're going to focus on exercise 7. Next week, we're going to focus on exercise 7. So what we're going to be doing today is going to be bringing the data into our GIS. And then next week, we're going to talk about, and we're going to revisit hypothesis testing that we had previously done. You know, we make these statements like, homicide rates in rural areas are higher than homicide rates in urban areas, and kind of mention things like small number problems. Encoding text as numbers. Oh, this is ugly. I dealt with this earlier today with Cameron, where we bring stuff and open stuff in Excel, and anytime it sees numbers, it wants to turn those like literally into numbers, even though your 820, something like your 820 number really isn't a number. It's just a string of numbers used to identify you. So a lot of times Excel is smarter than what it really thinks it wants to be. And so we can build uniform understanding of the data, and so that we can run some open-ended analysis and then start to develop these. I thought this was neat. EDA, exploratory data analysis. is basically like, kind of like detective work, kind of working through the data. And when we talk about big data here, the big data here, we're looking at a few million records, but there's databases out there. You go and scan in your, Food Lion card or what you bought or whatever, and people are making decisions about that store and you attaching you to socio-demographic economic data out there so that when you go to a particular store, you get stuff mailed to, they're doing the same exact thing. You know, I listen on my phone to Spotify or whatever. What kind of commercials do you think they're giving me? What's that?
Ones that they're partnered with.
The ones they're partnered with, but are they, sending me, toy stuff? Well, maybe not. Probably not toy stuff. Stuff that I want to do, travel stuff, wrestling stuff, whatever, whatever, and that are partnered with their folks there. So we need to be aware of data types, and we'll talk about those here in a little bit. The structure of data, our structure, and since we're quantitative geographers in this case and not qualitative geographers, because that's a whole nother can of worms, what does the data look like? I want to open up something in Excel. Excel is just a specific program, but it's got rows, it's got columns. I know what the rows represent, or I can figure out what they can represent. Each of these columns, each of these rows represent an instance or a record of each of these. And in a perfect world, we can turn those into a GIS where we look to make a one-to-one relationship with each of these. Faithfulness, how well do the data capture reality, temporality, how's it situated in time? So what we're going to look at today is gun deaths in 2021, because that's the latest data that we have. Other things about structures, what do the data look like? To me, this is what data looks like to me. This is what it is. And so things like data frames in R, Python, relations in SQL, those are all kind of saying the same thing for the most part. We can open these up in TSV values, CSV files, JSON, JavaScript, object notation, and now we have things called GeoJSON, okay, geographic JavaScript notation. We have a student sitting over here, Gray. He's working on some things where he downloaded data in GeoJSON format for amphibians in Western North Carolina. And he's going to be giving his poster at the North Carolina Geographical Society Symposium this Friday on that. But he was given data in GeoJSON. Why do we store stuff in stuff like JSON? Why would you store stuff in that? Why not? Why don't we just save it in feature classes? What's the use of JSONs? Did I stump Chima here? Yeah, object oriented, and they're software agnostic. So, I give someone a feature class, they're not going to know what to do with it in another application where these will be understood. And then we got records, rows, all these other things here. Because typically, and we'll actually start getting into this with XML, is metadata. This is how metadata really looks. If you ever opened up a web page, this is what your web page looks like. And so we got different variables, storage types. We have variables. Remember all this stuff we've talked about? Discrete data, ordinal data, nominal data. Oh, yuck. I don't even want to get into qualitative stuff. And so discrete data, continuous data. The one reason why we ran into problems with that Jaccard index, because when we look at number of stores within a block group, it's a really small area. So we're working with these values of 0, 1, 2, 3, maybe 4. Maybe one block group had 4. either 0, 1, 2, 3. When we look at values like median household income, they could have decimals, not decimals. They probably range from $10,000 up to $200,000. And so for 763 zip codes, we probably have 763 different values. Where that we're looking at the number of supermarkets, we might have values between 10 and 50. And so we've got 6, 10, 7, 11s, we have a much smaller range of these here. So I like these when we look at the different variables, because we're going to look at some of these variables right here for the vital statistics database, and we're going to start to figure out what they mean. And so that we can look at things like, what is the age and race of the people who died from gunshot? Because we just mapped all the gunshot victims. That's great and all, but you got information about age, race, ethnicity. That's better, because the 3 words that you don't want to tell your boss are, I don't know. And especially if we've got that data sitting there with us. And some of these data are going to be represented nominally or categorically. So we're going to look at, we have all these different categories for race, probably about 6 or 7. For gender, they've got a certain ones listed there as well. And so we can look at the structure of keys. We'll talk a little bit more about these primary keys and secondary keys later. Keys are basically like your A2O number. And so when you go to the Eagle card versus paying your parking bill or all that other stuff, even though they're on different systems, the one unifying thing amongst all those is your A2O number. And so we can treat those as keys throughout here. So one of the things I think what we're going to do here, how about we just start working with the data? Okay. Now, when we look at exercise 7 won't be due for 2 weeks. So we're going to start it today. We're going to come to a good stopping point, and then we're going to kind of finish it up next week. And so exercise number 7 here, we're going to work on it for 2 weeks. When we open it up, this is what we're looking at. And I want us to think kind of big picture about some things where that I'm pretty sure I've got. It's under week 8 right here, but. But using the skills here in the next couple weeks, and this is the assignment, you're going to develop a simple research hypothesis and prove it using the techniques covered in class using a short 1 to 1.5 page synopsis. This is nothing. People in geostats had to write a 5-page paper. Okay. We tried to look at cancer deaths. We might look at gunshot deaths, gun deaths here. We want a short introduction, short research hypothesis. Where'd we get the data? What'd you do to the data? If you cannot think of one, and we'll talk more about this next week, basically I'm going to just assign you a topic and you can do that one. Okay, but what we're going to do today is we're going to open up our ArcGIS Pro project here. And this is it right here. Does this look familiar to anyone? Hopefully it looks familiar to people who've taken geostats before. Somewhat familiar. Okay. And so what we're looking at here, we've got zip codes. I've got county sitting right here. I've mapped age, grade, rate. Basically, that's the age graded cancer mortality rates for zip codes. And so we took 20 years worth of data. We had to age grade it, because typically what ages of people die of cancer they're not compared to other ages, old people. So when you map death, basically you're just mapping old people. That's really all you are. And we saw that before with those deaths. Cameron was mapping where we saw them down in Moore County and Whispering Pines had really high cluster of death. Well, we got more old people there. So we can standardize by age, which means age grading. And all we're doing is just running a weighted average based on age specific death rates. Now, we're not gonna go through and do all that, do all that here. I've got counties in this feature class here. I've got counties here just as a reference. I've got age graded rates. And also, I went and mapped these age graded rates to look where there are clusters of cancer. Okay, age graded rates. This has taken over 20 years. And so I don't have a lot of consistency over this here, but does everyone remember this map right here? Remember doing this back in the day in geostats? Well, we're gonna do it in geostats here. And basically, these areas in red are hotspots. High values surrounded by other high values with statistical significance versus low values surrounded by other low values with statistical significance. I'm going to ask the $1 million question. What's the word high mean? High. Tell me in words how this algorithm calculates high. What's high mean? Ooh, let's ask someone online here. Above what? Average, exactly. We look at the average. And then how high, it's got to be a certain amount above the average or below the average. And so values that are near the mean surrounded by other values near the mean, even though they're near each other, they aren't clusters. And so even working with this and making these data, there's a lot of potential for error. One of the potentials for error is what we call the small number problem. Who's heard that term before? Small number problem. If we happen to have a zip code in there that only had 5 people live in the zip code, and there's some zip codes in here that are really small, and one of them died of cancer during this time period, what is the rate? 20% of people are dying of cancer in here. What's that going to do to the average? Move it up here. And so, what are ways that you can get rid of the small number problem? Normalization, that's a good word. Okay. Other things we can do is we can eliminate all the zip codes that have below a certain population. Because I really want to find the zip codes where 20,000 out of the 100,000 people died of cancer. That's what I want to see. But I don't want to say I don't care, but I know that 1 out of 5 is going to be more probably a statistical anomaly and really not reflective of what's going on there. And so I can go and eliminate anything with a population, zip codes with a population of less than 500 for better or for worse. Meaning, it's got 100 people, no one died of cancer, it's got 0, yay. But it's just probably a good 20 years or whatever, in addition to all the other things that we look at. And so I wanted to put this map up there as well. Now, when we look at zip codes up here, this is under the zip codes feature class. I think I've hidden a lot of the attributes, but maybe not. But when we look at these attributes, I have something called Toad Pop CY. That is the total population in the current year. I have household population, family population, group quarters, population density, total, I don't even know what that is. I have, what's that? Total households. That's a good, yes, thank you. Total households. There's a difference between households and families. We have white, median household income, poverty rate, SNAP per 1,000, green space, percentage of people receive SNAP, percent minorities, so just non-white population that I can map, people who live below twice the poverty rate. And as you kind of start to look at these, supermarkets, fast food, these are things that have been collected over the last few years. COVID rates. I get into some percent absentee ballots, clustering bins, changes. Oh, man, there's a lot of stuff here. Spending on fruits and vegetables. So I've got a lot of things here. And a lot of times when you put things like this together, like we can work with this for years. Chima and Tony, they're working on a database like this for block groups across the entire state. You only have to make this map once, and then we update it yearly or every other year, whenever they're gonna ask for updates. But then we can just zoom in on particular parts here. I wanna zoom in on this 7-county region, or I wanna go down to Anson County or whatever. But once we have this original database, I could do tons of things with this here. And then if you can notice, I got median age, COVID rates. This COVID stuff has changed throughout the entire state, and it's moved from eastern North Carolina to northwest of Charlotte, over the course of the pandemic. So I've got, tons of work that I've done here across this here, age grade and getting into some of the cancer mortality rates. But over here, I've got something here called ID. And if we look at ID, this is the actual zip code that it is. Zip code. What is one thing that you notice about the justification of this number right here? It's left and right. Why is this one left? When I start looking at numbers, it's right justified. It's treated as strings and it's nominal data. So this thing right here, ID, it isn't 20,000, 27,024. It's 27024. And if this led with a zero, that zero would stay where that if this leads with a zero, and this leads with a zero, and this has got a zero, and this has got a zero, but they're just kind of eliminated. That's what they call ghost of zeros. And so we can get rid of those. Because what we're going to do today is we're going to go to the North Carolina Vital Statistics Database. We'll take a short break. We'll take a short break in about 20 minutes. And because what I want to do today is just prepare this data so that we can start to save these maps and make sure we save them. So we're going to go to the North Carolina Vital Statistics Database. And I've already have it open right here. But this is what the Vital Statistics Database looks like. This is hosted by, I think, somewhere over at UNC Chapel Hill, the Odom Institute. You can read all the documentation about it here. But we're going to start to look at all the deaths. And this is what we're going to do because we're going to query out the actual deaths right here. And I'm going to click on deaths. And I can download all of the deaths in the state of North Carolina that happened in the year 2021. Now, this database or this file is only going to have about 100,000 people. Now, 100,000 is probably a lot to us, but it's not really a lot to someone who works in like really big databases. But when we start looking at like voter statistics and all the voter databases, we're looking at millions, for the entire state, or even millions to the hundreds of thousands here. Now, I've got a bunch of data here. I've got guide. I've got all these files here. I've got tabs. I got tons of stuff right here. Now, one of the things I'm going to open up here is the data. I've got the data description right here. And I also have this guide right here. Because I want to figure out, when I look at this, I got to figure out what I'm looking at here. Okay, I've got this guide. And then I've got this death data description stat. And I can download this thing as well. And so when I start to look at this here, this is the 2014 data. I've got something called CNTY-OCC. These are all the fields that it's going to have. Every single field. So we're looking probably about 30 or 40 different fields. So I can see if a person was pregnant. Did tobacco contribute to their death? Was it an injury at work? What is their zip code? Because eventually what we want to do is map these here. How old were they in years? We have race, and we can see the different race designations. We can see ethnicity, sex or gender here, date of death, birthplace, birth state, birth county, facility name, county of occurrence. And so when we open these things up here, We can start to figure out what are some things you want to do. You know, if we're going to be looking at gun deaths, you know, Chantel's going to want to know, hey, are these things related to certain age? I'm sure they are going to be related to certain age. But maybe we can look at different races. And we definitely want to look at location. Which one of these fields is going to help us put this on a map? I got this thing called zip code. Yeah, I got zip codes. So there's 763 of these zip codes in North Carolina. So we won't have the exact address. They hide these. Okay, next, let's download the data. Just download it. Okay. So I can download this. Okay. There's a couple different files we can download. I got something called .data. I'm going to download the one that says .tab. Okay, it stands for tab. Right, the little button right here, you hit tab, 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 tab. It doesn't allow us to download CSV, which are my favorites. And so I'm just going to download the data here. SPSS. R data, look at cool. It could download it in R. I'm just going to download this tab delimited data. And I got it. It's called Deaths 2021. I put the little parenthesis 2 there because, well, I've already downloaded this a couple of times practicing for this class. .tab. Do you think I can add this thing straight to ArcGIS Pro? Yeah, bring it into ArcGIS Pro. How do I do that? Just insert, or in this case, map, black plus sign. There we go. Let's see what this thing looks like. Where am I going to look? Downloads or wherever you save it. Me, I just click and saves and downloads, but you can click wherever you want to store it. So I can go to this PC or Timothy Mulrooney, downloads, and I'm going to click on this little deaths. What's it called? Deaths? Where'd it go? Anyone see it? Should I start yelling at Chima because he told us so? Why can't I see it? Any ideas why I can't see it?
Well, another option, you can bring it into the folder
Yep.
and then go to your folder.
I could bring it into my folder. Another thing is ArcGIS Pro might not like .tab files. Yeah, so we can open this thing up in Excel. Because when I go to this .tab file, when I just look at this right here, and I talk about the idea of software agnostic, it's a big fancy way of saying what? It doesn't recognize. So I go to this tab right here. If I just try opening this something really bad is going to happen here. Okay, really bad. Okay, I'm basically opening up in like Notepad. Who wants to open this up in ArcGIS Pro? You get an idea of what we're trying to do here? Yuck. All right, and actually you can see what I did with the voter database here as well. Uh-oh. All right, and Cameron mentioned, hey, let's open this up in Excel first. So I'm going to go to Excel. Let's navigate to this. Because it's going to give us a little wizard right here. We can save it as a CSV file. And like Chima suggested, let's open it up in a folder that we all know and love instead of this downloads, which has everything that I've probably downloaded over the last 2 years. And so when I open it up in Excel, I can just go to Excel. I'm going to open up a blank workbook, file, open, and let me look for my deaths here. I swear I know what I'm doing here. I've already practiced this. Uh-oh, why doesn't it see it here?
All files.
You gotta do all files here, because even here in Excel, it's saying, I'm just looking for the stuff that Excel knows and loves. Now, if I go to all files, okay, here we have deaths 2021. Excel, they can open up PDFs. It's probably not gonna look pretty in Excel. They can open up images in PDF. It's probably gonna say, I don't know what I'm doing here. And so I've got this tab right here. Double click on this. Now look what happens. Did it open up in Excel? No. Now it's got this little wizard here. It's called text import. And what are we going to say? It's delimited, meaning characters such as commas or tabs separate each field. And so when I use that CSV file, it's just comma separated. What do you think a .tab file is going to separate them by? Tabs. Exactly. So I'm going to type in something, tab, 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 next. So I'm going to go next. I'm going to say that it's a tab. And I'm going to say my data has headers also. Next. All right, so now dplace, CNTOCC, CITOA, OCC. What do you think these things represent? All that garbage we were looking at before. You know, all those file names, typically we used to use the word DDF, data dictionary file or data definition file, that tells you what all those columns represent. That's what these represent. Okay, next. I can go and tell you exactly what each of these represent. Oh, yuck. If I really want to, you know what I'd do here? I'd go to like zip code and say, I'm going to make that text, right? That's pretty slick.
Yeah.
I just saw that now, so.
I was like, oh, that's so nice.
Okay, I just saw it now. But I can go through and dictate, and typically we use the word typecast, meaning you force it to be a string instead of what Excel wants it to be. Because it says general, if it sees a number, Excel is going to want it to be a number. Doesn't know any better. Excel is used to working with numbers. And so luckily, I caught that one really quickly. And we can play with the dates right here, like death date. I just get a little concerned. I'm going to change the file format on that thing and change it into like weird dates, so I won't do that. And then I'm going to click finish. So I'm just going to import these things here. Look what I got. So now I've got this in Excel column. I got these things called COD. These are ICD codes, because we're going to have to go and look up these ICD codes that are specific to gunshot deaths. Typically, ICD codes, anything that starts with a C is going to be cancer. Can you look up anything that starts with a C using your query, using a ArcGIS Pro query? Of course. Give me everything that starts with C. And we can look up specific things. I think like X are going to be like accidents, poisonings, things like that. Motor vehicles, anything with an X that we see like that, right there. But we can see also multiple codes. So like this person probably had multiple forms of cancer when they passed away on January the 4th, 2021 at the age of 62, who had a marital status of S, and they had this particular race and this particular place, and they weren't a veteran. Look at all the information. When you die, look what you get to become. You just get to become one of these records right here. Yeah. I've looked it up before. My grandmother's in here for the 2014 stuff, and she really is. Yeah. So you can look at these here. Okay, because you're probably starting to think about, hey, I can make a nice map out of this, and then I'm going to start to, look at the causes of deaths. Are there differences between African American and non-African American? Are there differences between different locations? Because if you go to that database, that zip codes, I bet you one of those zip codes is labeled as like metropolitan or micropolitan or rural. So now we can start to make research hypotheses with those. Now, don't let me talk about rural because Chima can tell you all the different definitions, ways to define rural. It's like 9 of them. Okay, and we kind of get down those rabbit holes that we don't want to get down here. But that's why we write these, little papers, or that's why you do a dissertation, or that's why you do a master's project. Okay, so we've got this here. Okay, you look at my zip code is left justified. I'm excited about that. You see my zip code's left justified? I didn't think of that.
We live in RGIS and it didn't stick.
They didn't like it? Okay.
Maybe I missed something.
You might not have. I think ArcGIS Pro is still seeing these numbers here. It's not pulling the attribution from this to that because you see these little green things here. That means that like, hey, I've forced it to switch. I've changed it or whatever, and it might not take, to be honest with you. Okay. So now, what's a good file format that I can bring into ArcGIS Pro? CSV. And a couple of things that I've done here, if you look in the table of contents, in the left right here, I've imported some depths from 2011 as CSV files, just to give you an idea as to what these data look like. Because when you open up the 2011 data versus the 2016 data, you're going to see some major differences between those. At some point in time, you're going to have to figure out how to make those things line up. And that's where that 80% of data preparation comes from. That's where you got to go and read through that documentation and figure out, how do I make these things match up? Tobacco use was added in 2016. So if your boss comes to you and say, like, I want all the tobacco related deaths from 2001, you're going to have to say, it wasn't added until 2016. I'll give you the 2016 and above. ICD codes change and whatnot. Okay, I'm not adept or up to speed on these things as, people who kind of live in this space full time, but look at all the things that we can capture right here. And so when we look at deaths, or we look at these deaths, this CSV file, I can open this thing up. This is the standalone file right here, which is going to look different than the 2015 stuff. Look at this here, D place, county occurred, while we have barcode, hospital, E county, R county, D date, DHT date versus D date, age years, age months, and I don't know why this changed. I'm kind of looking at people who might know why it changed, but I don't know why it changed. But I'm sure there's a reason, maybe aligning with some national standard or ISO-based standard, who knows? Okay. All right, so what we're going to do here is, how about we just save this file as a CSV file, and then we'll add it in. So we're going to go File, Save As, Browse. Okay, and then I'm going to store it as a CSV file. So I see this thing here, CSV MS-DOS. And then I'm going to store it in my ctemp file just so I know where it is. And also because I know I got rid of all my temp stuff the other day. Here it is, it's blank. So here are my deaths for 2021. I've got everything sitting right here. When I go to the bottom, look how many records we're looking at here. We're looking at about 122,000 deaths. I don't want to say it's not that much, but they're increasing every year. Is that a good thing or bad? Can't really tell because the population of North Carolina is increasing. Now I can go back. Let me get rid of this. Let me get rid of this. I can go to my map, my add data, this PC. Now I'm going to go down to my temp. Can you log in there, Erica?
I did the Control-Alt-Delete.
Let's try it again here. I want to get you going here. Here it is.
It's that client.
I've got that password in a special place. Let me get it for you.
It's here and you pick up.
I really know what I'm doing here. Okay, here we go.
We'll take a picture. Take a picture of this thing. Looks like a picture.
Choose that one. All right, I was just helping people log on to here. And now look what we've got. Look what I have in my standalone table. Is everyone kind of following me? You got it here, Chantel? Looks like you got it.
No table.
What?
We have the same number.
Did you do tab delimited? It's not work. Yeah, just tab. Did you do anything else besides tab?
Yeah, we use.
No commas.
Oh.
No commas. Just do the tabs. And so when you do the delimiters, when you do those delimiters, make sure you only do the tab, because if it sees a comma in there, what's it gonna do? It's gonna assume it has another column. So we had some people, and honest mistake, and to be honest with you, the best way to learn stuff is to make mistakes. Because anywhere in there, if it sees a comma, like a character or say a town name or something like that, once it sees a comma, it's going to move it over a column. And so you're going to have your columns not lining up with each other. And that's going to be ugly. And you're going to have to go back and edit 122,000 records, which I'm not going to do. That's why they invented students. Okay, and for now, how about we take a 10-minute break? We'll get everyone caught up here. And by 6:20, what I want us to do is have this table added to our standalone table. Okay, I want us to get to that point in time, so we'll do that. I'll be back in a second. I got to go do a couple things here, and I'll be right back here. And
That map, I found that map. I put that map in as a layer.
Okay,
This is yours. I actually got it up under your layer. It was blank map.
okay, cool.
But no, but it disappeared.
Let me see.
No, not on
Oh,
this.
okay.
It was, cause I was gonna add a layer.
I'll be back. I gotta go make a call here.
Here's Kenny. Did I get your name right? Chima.
Yeah, Chima,
Chima. So,
CHIMB.
my name's Erica. I've been working with some stuff at home and it's been, but something's going on with that and I'll deal with that, but I'm here. And I had added a layer on actually that map because I wanted to save that map.
Is that what yours online?
Yeah, I'm online. ArcGIS online, right? And it was under him, actually, it's Chimaruni. And, wait a minute. ArcGIS online. Well, that's what I was supposed to say. I'm on. But, it was a layer and I added it on my, but then it's.
Here or home?
I'm not home. But it's, I'm still blank. I just came out and I said, I think you told me to be safe. So I want North Carolina, I want to see the world, right?
Okay, just not that.
Yeah. And he, right?
Check here, check. Search.
Oh, look at you. What was that?
Yeah, that was something like this.
What was that?
It was PM 2.5. So this was.
Look at you. What about North Carolina?
Yeah, so just search here.
Oh, but I wanted it as a base map.
As a base map.
Right, because everything else I need to layer it on. I want to layer it on. Everything, because that's all gonna be like forever and ever.
So this is North Carolina.
Yeah, so did I get that before? It's on the, I checked.
So just search.
Yeah, I got my, oh, you went under my mind. It's that map right there.
So if I add this, this is.
Okay. There's something I'm missing in my thought process. And I'm gonna tell you what I can't pull this out. Export. It's just that I'm only dealing with this.
It's probably to.
Just to say that I don't wanna look at anyone else. So I can't do that.
Yeah, it depends on how. So you can save this map with this. You can save this on activities like this. So exporting, do you want to export it?
I want a futuristic thing. I'm looking at base maps, static maps.
Okay,
Everything will be static. And I want to, you know,
you
but
can export like PDF, static PDF. Yeah, you can do that.
maybe I need to save this one first. I'm gonna save this one in my stuff.
But it automatically saved to your.
I don't know what I did at Carolina base. Some categories. Oh, there we go. I have a lot of things. Says started events. No, that's my old stuff. I can just say, I know, it's, see when you do tutorials. Want to, okay. All right. And then I can say from.
So to explore.
I have. You tutorial, what you working?
Still working on what we were working.
I haven't took this class in 2017. The GI, the base. Just had to do my. What areas? Like just geographical.
Within this region. This. So global region 7.
No, we did.
But then travel extension.
Did you say it again?
That's why, well, mine is education, I'm just way out there, but I'm looking at just the state.
I'm trying to find the export, but I think it's Pro. Pro.
Okay, I'm ArcGIS, okay, but I have ArcGIS Pro. So, it's not on here.
They should. Yeah, you should be able to export it to the springs.
Mhm.
Your friends figure out. There's a band, this is the size. Change it to any size. I from PDF. That's just. So.
Okay. Okay, now I'm going to try something else. It's, okay, I want to go back. So, I'm adding another. And I'm gonna tell you, I'm gonna look at my. What we're gonna say, shut up. Gee. That's so big. Yeah, it's so short.
Is that these added? Oh, good, good, good. You all set, Samuel?
It's not even seriously.
And
So
here about just here,
It should be with species. Because we're part of the.
I just like doing everything on checks. That's what I like doing, so.
Might have to, type out UNC University on there.
And aren't those, some of those on, NC1 map? Okay.
Yeah, NC one. What's interesting, which I didn't know, was that the residents will pay.
Okay.
One of his.
All right, so we'll start here. We got 6:21. I want us to get out of here a little after 7, maybe 7:10. Okay, so we've got in table of contents, we've got deaths 2021. I want to get to a point in time where we can turn this into GIS data. So if I right mouse click, open attribute table, look what I can do here. Okay, I've got these CSV files. If I look at the zip code, what's the one problem you see with that zip code? It looks like it's back to being text. We'll figure that out. We'll deal with that later. Because what we're going to do is we're going to go extract out all the deaths. The other thing you see here is if I right mouse click here, you see things like calculate field, calculate geometry, summary, fields, delete, they're all grayed out. So one of the things that I like to do first is export this thing, this whole table, to a ArcGIS table that's going to reside within the database. Is that what you do, Chima, probably? Okay, because these are standalone tables, but you notice this one doesn't have a file extension because it's sitting within the confines of the database. So I'm going to right mouse click, data, export. And I'm just going to call it deaths 2021.
Yes.
Here it is. So look what I have here. I got deaths 2021. I've got everything here. Now, under this code 1 right here, these are all of the ICD codes. So I see a W19, a W06. I see a couple W06s. So I want to figure out what these codes are. And if we go back to our modules here, I've got a list of ICD codes. I've got this mass fits code. And so I can open up these ICD codes here. And in this particular one here, I think this one's from Pennsylvania. I was looking specifically at firearm assault.
Let's do that.
If I look at these codes here, I see stuff with W. I don't even know what the W is, but Control F, W.
Let's see one.
Falls. So anything with W, falls, hanging, strangulation, suffocation, any of these here. So when we see these W's, firearm deaths, W32, W33. Because eventually what I want to do is I want to start to figure out what these codes are. So I got 122,066 records. I want to figure out and I want to extract out everyone who died of a firearm death. So there's a lot of, I can use the Google machine here, but I've provided a couple of resources here. So if I go to ICD codes or this mass fit codes, ICD codes for deaths. Homicide by firearm is X93 to X95. Or U14. So when we look at this right here, when we look at these ICD codes, now there's different ICD codes. ICD stands for the International Classification for Death. So when you die, you get some little code assigned to you of what you died of. And in some cases, it might be multiple things or whatever there. In some cases, obviously, it's going to be none here or just one. But homicide, assault by firearm, U14, U014, X93, X94, or X95. Can we run a query on that? Of course. Okay. Because now we'll just create a subset of data from this. So I'll go to map, select by attributes. What do I want to do? I want to do a new selection where what? Code 1 is equal to U014. Yeah, I can help you after that. What? We'll find something somewhere, so. X93. X94. Now, I don't know what the difference between X93, X94, and X95 is. That would be a really great presentation for the end of the semester. You telling us the differences between these. You go through the weeds and figure out what's the difference. Why do we have 4 different codes for U14, X93, X94, X90? I would love to do that. Other thing is, why do I have the word or here? It can only be one of these. And so, or basically means it can only be one of these. Now, if it's a C67, that's obviously not going to be part of that. I'm going to click apply. And just for the heck of it, look what I see here. 887. $887. Are we at a good point here? Is everyone here? You guys all set, Andy, Michael? No? Okay. What are we catching up to? How about you, Chantel? Are we here? Yes, sir. Okay. You got that query right there. We're good to go. You found 887. Good. 887. And we can export that to a table. Too. Now look what we have here. Asian years, 67, 40, 57, 25. Do these look younger or older than the average age of death in North Carolina? Probably on average a good bit younger. And so a lot of times, do these numbers make sense? Okay, we've got veteran status. So, we can see there was one veteran killed here. Workplace injury, and the zip code. So we got 887 gun deaths.
Question. So yours is highlighted within the field, right?
Mm-hmm.
Is that like the top 877?
Nope, because I clicked this little button here that says show selected. Show selected. So here it is amongst everything, you'll see it right here somewhere. And then I just want to show the selected. Okay. So I want to now create a new data set just of these 887 and run my analysis on those, the histograms, average age, all that other good stuff here. And we're just going to export it just like we did now. So I'm going to right mouse click, data, export table. I'm going to call this gun, not gunned, gun deaths 2021. Look what I got here. Now I got 887. What if I want to see the average age of the person who died of these 887? How do I do that? This is like week 1 from Geostats, week 2 from Geostats. Summary, well, you're thinking too hard even then, Chima. Right mouse click, statistics. So now we can get a nice report. And look at this. What's this thing called? Histogram. Isn't this what we want to do? Is this what you're thinking, Chantel? Exactly. So look what we have here. A nice histogram of the age of people who died of gunshot wounds from age 2 all the way up to 97. And we haven't even looked at the maps yet. That's the good thing about this. We haven't even looked at the maps. Okay? I can click on I think my little properties right here, and look what I got here. The mean is 32.9, the median's 30, standard deviation, rows, min, max, sum, skewness. We talked a little bit about this in geostats. How compact the actual curve was, because you notice it's skewed to the right, and then skewness measures in what direction does that tail go, because this isn't really a normal distribution situated about the mean. Okay, but I can export these. Oh, oops. There we go. There we go. Okay. Look at that though. I can export this thing, import it in. You know, 20 minutes ago, we were just downloading .tab files. Now we're doing some neat things here. Who wants to make a map of this? Of course we do. That's why we're here. So, you know, when I get a couple of questions that come up as to, you know, can you leave this stuff in Excel? If you're good at Excel, let's leave it in Excel. Me, I love doing this stuff in ArcGIS Pro. Now, the next thing I want to do is I want to map these. Okay. Don't I already have a zip codes data layer sitting here that I would love to add a column here that says number of gun deaths? Love to. Because I got everything under the sun here. Median household income, number of supermarkets, number of fast food, everything you can think of. I just want one little column here that just says number of gun deaths. That would be cool. All right. And while I'm here, I'll get rid of everything. Because while we're doing this, we can do things called merge. Like, let me bring in the 2021, the 2020, the 2019, 2017, the 2016. I can click a little button called merge, and it'll merge all of those tables together. Back in my day, we used to call it data loading. It was called loading, which is slightly different than merge, because loading was you could bring in DDFs and things like that, but we won't worry too much about that now. But we can merge this because we're just working with 2021. Cameron's going to want to work with 20 years worth of data. Okay. And Alana, who wrote the PhD student who wrote the paper, she worked with 20 years worth of data. But we ran into problems when we got to 2014 because all of those were messed up. So what she did was she did the 2015 to 2021, the 2013 to the 2001, had two tables, and then we only had to match the data once. You know what I mean, Cameron?
Yeah, I was looking at how to merge stuff, like.
Yeah, but we only had to merge that weird stuff once instead of, all right, let me merge the 2002 to the new stuff, the 2003 to the new stuff, the 2004 to the new stuff. It's a lot. This is time consuming and it gets really ugly quickly. So we're kind of showing some of the Cliff Notes. Anyone know what Cliff Notes are? Okay. I know Erica does. What's that? Yeah, I didn't know anyone knew what they were. Okay. Cliff Notes, yeah. I think it used to be called Cliff's Notes or something like that.
Cliffs.
Yep. Okay. There's some old people jokes there, millennial jokes. No, what am I? I'm Gen X. Gen X jokes.
And I just went through that today. I just learned that I was Gen X.
Oh, okay.
And I have to say, Post was saying, how do the different generations respond to insults?
Mhm.
And it had, I think it was boomers, you're rude, and millennials like you're mean. Gen X said your mother.
Yeah, I would think of some things here, but I would not. Things I would say to my friends really would not.
When I saw that, it was so hard because my students, when they would insult me, I would say, they come and my house. They come out, but I would be, I didn't realize that.
Yeah.
We, you know, I would say, my girls don't talk like that. They come and my house. You know, I would say those things, and I was like,
All right. All right. So next, what we've got here, we've got a list of, I want to start turning this into spatial data. I got some nulls here. I got some sorting here. I can look at a couple of these. I see, look at 28311, 28311. Look at all these 28311s. I want to count the number of times each zip code appears. What operation do I run? Not the count, but it's called like a count. It's called summarize. To me, summarize is a powerful tool. It counts the number of times something appears. So I can right mouse click right here and I can go to summarize. I'm going to count, and I know a couple people are thinking, hey, those are still numbers. What are we going to do about that? Don't worry about that right now. Okay. So I'm going to click on summarize. Okay, I'm going to click on summarize. I'm going to count the number of times each of these zip codes appears. A couple of you are looking up here. You're like, hey, I got 10037, 166. You know, I got a couple of these weird numbers. What's going to happen to these weird numbers? They're not going to be joined because we don't have anything that starts with a 1 or 17 or 16 in North Carolina. It just goes away. Sorry. You know? So our case field is going to be zip code. Some of the things we can do. Hey, while I'm doing this, let's average up the median age. Okay. And we can run some other summaries that are going to be non-spatial too. Like race. Let's count the number of times each race appears in these deaths. And then we got to match it back. Like 1 is white, 2 is that, or whatever that, whatever that DDF document tells us. So age and years. Typically, I like using these for quantitative data. And so race is going to be what? Race is, it's 1 and 2, but I don't want to average them up because it's just classification. So we can address that later if need be. And my case field is going to be zip code. So now look what I've got here. I run this. I run some statistics. I have 353 zip codes. I've got a zip code where 13 people died of gunshot wounds. I got 2 of them, 3 of them where 13 people died. The average age was 33, 26, 21, 35.5, 28, 33. Who wants to map these? I do. I'd love to map these. I know Chantel wants to. This is, we might be doing her master's PhD project here. Who knows? No, this is really neat. This is interesting things because we're doing a lot of the quantitative and we're doing a lot of the qualitative. Because Chantel, when she does her work, she's probably just not doing it on 2021. She's going to have to go through and bring in 20 years worth of data, making sure it's consistent, going through the documentation, really getting into the weeds that we didn't get into here. Now, the problem that I see here, and Cameron kind of noticed it before, when I go to run my join, don't run the join now, but when I go to run my join, watch what's going to happen. I'm going to run my join on my ID here, and I'm going to run on this statistics, and let me see if it does it. It says join has no matches. And when you go back to the ID, and you go back to the code here, they're the same thing, but one is a number, one is a text. That's gonna be a problem. I want the text to line up. You know, this computer is stupid. It's gonna say, hey, I see a code there. It's called zip code, but it's not gonna line up with what I want because I don't have anything there that matches up.
You create a new field.
Exactly. Yeah, and that's what we're gonna do. We're gonna typecast it. That's all we're in. This is what we call typecasting. So we're gonna go to fields. We're gonna create a brand new field. And what are we gonna call it? I'm gonna call it zip text. Yeah. Instead of making it a long, okay, long is gonna be an integer. I'm gonna make it a text. And I'm gonna make it 10 digits long. How's that sound? There's a save button up here, but here it is. Under fields, I'm gonna click save. And now, what could I do? I could just calculate this thing right back in. What's that? It's under layers, but you can just click the X and then it'll say, are you sure you want to save this? And just say yes. That's what I do. And so now I've got zip code. And like Chima said before, this is being stored as a number. We're going to force it. Now I'm going to just calculate this field and I'm just going to calculate it to be zip code. So now look what I have here. I've got a field which is left justified being treated as text. I've got the frequency. Now I can run my joins. All right, remember that join? Are you guys all set there, Andy? I like when people work together too. Good. Okay, now let's run our join. Yeah, which one? Add in the zip text?
Zip text, I have that, but now joining them, like the calculate.
Okay, so we're gonna right mouse click and we got something here called calculate field. And so what am I gonna calculate? I can do lots of funny stuff to it, but I'm just gonna double click on zip code. I'm gonna calculate that brand new field in. Basically, zip text is gonna be zip code, but this time it's gonna be a text instead of a number. So this is what I mean by typecasting, meaning I'm forcing it to be a text. Did we do that in Python? What did we do in Python? When we printed out strings, what did we do? We put the little str thing around it so that it could be part of a output string. Yeah, we're basically reclassifying it as a string because I want to print out the sum of this number and this number is this number. But when I put the little plus sign there, it's like string plus 10. I don't know how to reconcile that. So we just force it to be a string. You know, or get parameter as text. And now we got to, hey, let's turn this into an int or turning it into was it a float? In Python, it's turning it into a float, where that in ArcGIS Pro, we call it a double. I guess we can call floats here too. Now I can run my join. Now we got all this fun stuff here. So now I got joins and relates, add my join. Okay, so my zip codes, I think it's called ID, right? I'm pretty sure it's called ID. I'm going to join it to my deaths 2021 statistics. Zip text. I like to validate my join. What's it say here? I ran a join for 311 records. What does this 311 represent? The amount that we're able to join. All of the zip codes that had at least one gun death. Now when I open up zip codes, let's see what we have. All right, we got ID, total pop. Let's go all the way to the right. What do I have? Frequency. What do these nulls represent? We didn't have anything that made a join there. So now can we go in? Now, if you really wanted to, we can select all the nulls and put values of 0 in there if you wanted to. If you want. But now, right mouse click, let's go to my symbology. Instead of age graded rate that I have here, let's go to this thing called frequency. Look what we have here. Your map. Now, anecdotally, what can we say? Higher in urban areas, rural areas. You know, I live over in Greensboro over here. And I think you can see, maybe see the outlines. No, you can't really see the outlines of the zip codes. It's not showing those zip codes because they're not values of 0, they're values of null. And so Chantel might want to go back and clean up the nulls and say, hey, let's select all the nulls. Let's find everything that's null and then replace it with a 0. But now, does this make sense? Does Southeast Raleigh have more gun deaths than the other parts of Wake County? Which one's Johnston? Is this Johnston County here? Now, I'm going to go replace those nulls with 0 because I want this to be a good stopping point because next week we're going to go do some hypothesis testing with the urban and the rural. I think we're going to come to a good stopping point right here. So now what can I do? I can just median age in years, frequency. Let me do a map. Select by attributes. Let's find everything in the zip codes where frequency is null. And watch what I can do right here. You see everything where the frequency is null? Just like we did with Cameron. Instead of doing everything recalculating, I can right mouse click, calculate field. And this computer is smart enough to know that, hey, I'm just going to highlight everything in blue. Uh-oh. What did I do wrong? Usually when I ask what I did wrong, what? I know what's wrong.
Do you have to tell it null equals 0 or something? Like null is?
I already did that here. I know what the problem is that this is a joined table. And so, yeah, I would export this thing to its new feature class because this thing here going from object ID to the right, this area right here, this isn't part of the attribute table. It's just joined right now. And so these nulls are just placeholders. They're really not cells. They're just placeholders for the original table, which is sitting under that statistics. And so I could right mouse click, go to data, export features. so I can do that and make this map complete. But I've got this map sitting right here, ready to go. And you know what I'm gonna do? I'll probably do that and look to finish up here in a little bit. And I'll call this zip codes final. Oh, no, I don't want to do that. Why? Because it's just going to export those out. So I'm going to clear. I'll just export the whole thing out. And here it is. So now I got the 763. Now I've got this frequency right here. That's now a permanent part of that new feature class. And now I can just calculate that frequency, calculate field, make it a 0. And now I can right mouse click on my symbology. There we go. There it goes. How's that look? We like that map there?
Would you want to use a quantile for this, or?
Quantile is not going to work just because about half of these don't have anything to begin with. So I'd probably just go with some sort of natural break. But
As a Jenks method.
okay, yeah, Jenks would be good too. To me, I don't like that 0 to 1 right there because there's a difference between 0 and 1. 0 means it had nothing, you know. But for now, we'll just equal interval. I don't know. That's even going to be worse. Yeah, I'll just do this one for now. So look what we got here. We got a map sitting here ready to go. We like this. We feel good about this one. Now, a couple things that I'll mention before we leave is that we've got probably about 100 attributes here. So we're going to start to make maybe relationships between party affiliation or, you know, maybe policy, you know, maybe some things related to policy like gun control or whatever. But somewhere in here, I should have something that says like urban, rural, something like that at some point in time. Aha, metropolitan, micropolitan, or rural. So I have metropolitan, metropolitan is large cities, micropolitan, small cities like Greenville, Wilson, and then rural is going to be neither metropolitan or micropolitan. So now I can start to see, hey, let's query everything that has more or less or whatever. And that's what we'll get into with our statistical testing. The last thing that I'm going to talk about is I want to start to merge data sets. And so under analysis, I can go to my tools. I'm just going to type in the word merge. Because at some point in time, Chantel is going to want to do more than 2020, 2021. So I can look at multiple input data sets like my 2015, my 2016, my 2021. And when we start to look at these, you see these are consistent. Now watch right here. If I go to 2011, I guess it works out too here. Okay. I must have already typecast them all too. But I can merge all of these files together. This isn't too bad. It looks like I've already moved all those over. But now we have a whole set of merge rules that now I can start to combine all of the different tables together into a single table. That'd be cool. I've just merged 4 years worth of data into about 500,000 records in 30 seconds here. Now you can append these in Excel back at the CSV file.
I think why mine looks a little bit different from yours.
I was messing around with some of these buttons, so who knows?
Was that like the output field or the source or three?
You might have a different version of ArcGIS Pro. I've got 3.0 still. So,
That makes sense.
yeah. So now I got this merge file. Look what I've got here. 389,000 records, death dates. Uh-oh. Look what happened to all the 2011 stuff.
Blew it up.
Blew it up. Why? It's got a different format, different attributes. So I've got to go through that dialogue and make sure that stuff matches up. Watch here. I go up to here. Some of this gets real ugly real quickly. But when we go to that merge, we got to make sure those column names are the same because this computer isn't smart enough to figure out DTH state or date state isn't the same as D state. And so what we need to go back and do is, all right, let's go back to the 2014 data descriptions here. Let's make sure these things line up. Here's the guide for 2013. And let's look at this. Here's the little code book here. And make sure these things line up. Because this will get really tedious really quickly and you'll get a lot of bad stuff that happens here. So what I want us to do here, let's get to a stopping point right here. Let's have a map because next week we're going to do some hypothesis testing. And so we can basically write a short little paper here. Now, what are some of the things we did today? We took data from Vital Statistics database and brought it in. We figured out what the proper ICD codes were for gun deaths. We exported that to its own table, and then we did the same exact thing over and over and over again. Because while we're all finishing up, look what I've got right here. I got the voter registration database for Alamance County. Look at this thing. This is pretty cool. A big, gigantic text file. Who wants to do this? NC voter 1. Watch what I can do here. So map, plus sign. What do we have? This is the voter, all the voters, registered voters in Alamance County, North Carolina. Look how many of them there are. I'd probably say, I don't know, 40 or 50,000 of them right here. Yeah, NC voter. I've got a last name, first name, 130,000 voters right here. Is there a way I can map these folks? Look at this. We got the address of every voter right here. If they're verified, their mailing address, their city, their phone number, when they registered, their race.
Burlington? Is it in Burlington?
Yeah, this is Burlington. And their party affiliation. Gender code, birth year, age at the end of the year, driver's license. So we can see this 58-year-old person here doesn't have a driver's license right here. So that I assume they'll show their ID in a different way. But they also have their precincts, zip codes, and everything. Can we turn an address into a map? What's that process called? That's that geocode stuff here. It would take really long time to do this, and it would cost a lot of money. Oh, yeah. Other things that we could do, though, is right here, we got a zip code. So maybe you can map political affiliation by zip code, just like we did now. So now we can see what zip codes have the most number of Republicans, Democrats, and unaffiliated. Now, that doesn't mean that's where they're going to vote. I'm unaffiliated. But that doesn't mean what they're going to vote, but you can see what they generally politically. So, but we got a zip code here for a location. If you really want to map these folks out here, go ahead. Take a long time. Ask Samuel how fun it is. He went and did it all over and over. He's run all this stuff here. Takes a lot of time to run these things, run these algorithms. 130,000, and this is only one of 100 counties. So you can bring in the whole file here. I bet you ArcGIS Pro will be able to take in all 7 million records. Take a long time. It'll probably take hours and thousands of credits to geocode these. And then don't get any ideas.
Oh, I tried to see if I could geocode the other day.
Okay.
It's not an accessible tool.
Okay. Yes. I think I put credits, limit credits on everything.
Yeah, I couldn't find the tool to be able to do that.
Yeah.
And I was looking to try.
Yeah. So because geocoding takes up, it'll gobble up resources. Network analysis will gobble up resources. Okay. So we've got the idea of a couple of really big data sets. You can make a whole living just working with this voter statistics stuff here. You know, look, like, did you know your information is sitting out there? You know, you can go look up your own. You can go look up mine. See, you know, you can see what where I live and all that stuff. That might be kind of interesting.
I just saw a commercial said that was creepy. He said something about looking up your boss's house and what they paid for.
Yeah.
Oh,
You could do
that
that.
was a commercial.
Yeah. Oh, yeah. It's easy enough to do.
I'm just
Yeah.
curious.
Yeah, we could go to the Gopher GIS and see exactly what your boss paid. You might not know how much they owe on it, but
There was a commercial about that.
Yeah.
Because he was looking up and said, "You can do that for yourself." So,
yeah. Oh, yeah. And so we can go do this same thing, map, plus sign here. Mulroney Timothy, downloads.
Then some people need to.
I gotta go and refresh it. Yuck. We'll forget about that for now, but I don't think anyone really cares about, look at my stuff here. But those are, you can build these big databases and really facilitate some powerful data-driven decisions related to voting and maybe policy related to gun deaths and all these.
So it's
Other
the
thing.
internship that I'm starting, it's like, we're looking at, it's like, we're gonna record data and then we present it to policymakers. so
That would
they
be
can
good.
make informed decisions
No,
about
that's
where-
good. Data for data's sake isn't gonna do anyone any good. So we'll end it right here. It's like 7:08 here, so. $7:08, and we should be good to go. Yeah. So we'll leave it today. Take a look at the exercise, kind of maybe get some ideas for some of the things, research hypotheses that you want to make. Next week, we're going to talk about, do a little presentation on t-tests and all that other good stuff, and make sure you come to make sure you click save. And we should be good to go here. Okay. So everyone online, thanks for joining us here. We should be set. And come to geography symposium. What's up?
Yeah, I missed the point. How did you, when you changed those null values to 0, did you use codes or did you use the helpers on the calculate field?